This video shows the design and installation of a 30 amp shore power system on a Catalina 275. When we ordered the Catalina 275 from the factory, they didn't have an option to get a shore power system on it, and we wanted to have electric propulsion, so we needed a means of charging the lithium battery in the electric propulsion system. So we added a 30 amp shore power system to the boat. We used a smart plug 30 amp dual configuration 50-foot cord set with shore power receptacle that was included with it as a kit. And then we used a Victron Energy Galvanic Isolator. Used a 1/2-inch thick Coosa board to mount all the panels and equipment, so we weren't drilling holes in the fiberglass in the boat. Then we used Blue Sea Systems 120 volt LC panel, a 30 amp panel that was required as the protection where the power first comes into the boat. Then we used a Blue Sea Systems AC main circuit breaker panel, 8409. That's a 30 amp main breaker, has a polarity indicator, and has 4 15 amp breakers included with it. But that panel didn't come with an enclosure, so we had to get a separate enclosure, a Blue Sea Systems enclosure, 8409. Then the Blue Sea Systems 360 panel with 120 volt AC dual outlet for the AC power outlet that was added to the boat, and then an insulating cover for that. And then the main line coming in, bringing the 30 amp power into the boat, is Encore 10-3 marine grade flat triplex electrical cable, and then Encore 14-3 marine grade flat triplex electrical cable was used for the branch from the main service panel to the battery charger. Then there's some shrink sleeve connectors, and all the wiring was enclosed in 5/8 inch wired split loom conduit flexible covers that run up underneath, mostly hidden below the hatches that are in the cabin of the boat. Here's the Catalina 275 on the shipping trailer as it looked when we received it. This layout of the Catalina 275 shows generally where we ran the shore power system. It came in the starboard stern, ran forward a little bit to the first components, and then further forward to where the main 120 volt service panel was going to be installed. This shows the starboard aft portion of the boat where the inlet connector is going to be installed, the galvanic isolator, and the inlet breaker. Locations for all the equipment was marked with this blue tape. The one on the left is the shore power inlet. The one in the middle is where the galvanic isolator is going to go, and then the one on the right is where the inlet breaker box is going to be installed. This is showing where the smart plug inlet is located on the stern of the boat. This shows where the inlet breaker, the 30 amp LC inlet breaker box, what it looks like in its enclosure. The enclosures are water resistant. This shows both the galvanic isolator and the inlet breaker box test mounted on Coosa board. This shows the power inlet fitting up in the upper left, and then the Coosa board that was used to mount the galvanic isolator and the inlet breaker on. And the CUSA board, all the CUSA boards were installed just by gluing the board, to the fiberglass using the 3M 4200 adhesive. And where you needed, a little chalk of CUSA board, was used to get the board, to conform to the fiberglass surface better. This shows the 120 volt main distribution panel, just with the cover opened before it was installed into the boat. This shows the completed installation of the galvanic isolator, with the ground wire comes in from the back of the boat, goes into the galvanic isolator, and then on over to the main inlet breaker panel. So the galvanic isolator is intended to protect the boat from stray currents coming in through the shore power cable that could damage the submerged metal components on the boat. The water resistant Blue Sea panels come with a variety of cable glands, and you just have to cut the penetrations for the cable glands and install them. They work quite well. The inlet breaker panel is required by code and is intended to protect the vessel from voltage surge coming in through the shore power system. So the panel senses, the surge and breaks, the breaker cuts off the power so that the rest of the boat hopefully doesn't catch fire and burn up. This view just shows what it looks like aft on the starboard side, where all this equipment was put in for the shore power system and the electric propulsion, that with the cables, put in looms and hidden wherever possible. This is a view underneath the galley area where the cooler storage is, and just to show that there is no access to the area where the 120 volt outlet was going to be installed. The only access is from the outside. This shows the opening for the 120 volt AC outlet. As you can see from all the marks, it took 3 or 4 different locations before I could find a spot, where I could cut the opening and the box could fit, behind that mounting surface without, hitting other things. This shows the Blue Sea dual 120 volt outlet installed, and then the cable pops out of the back of that and exits the surface where it was mounted and goes over to the 120 volt service panel. This shows the CUSA board glued with the 3M 4200 to the fiberglass surface where the main distribution panel, the main 120 volt power distribution panel, is going to be mounted. This shows the 120 volt service panel installed. You can also see where the battery charger was used on one of those breakers, and the outlets are on one of the other breakers. This view of the aft part of the cabin just shows how clean the installation of the shore power system is, where virtually none of the cables are visible. So here's the Catalina 275 in the water with the shore power system all installed, and it's been in use now for a few months, and it's gone really well. I hope this video was helpful and given people some ideas for how they might install the shore power system in their own vessel.